thank you. We've had some mention of cybersecurity already today, and of course, one of the challenges of cybersecurity is joining file sharing sites, or indeed using USB ports, which makes it incredibly challenging to share very large files, as this PowerPoint is. But you will get a PDF afterwards. So, delighted to be here. I look after wireless access across BT, which is quite a broad remit. I look after technical strategy and target architecture development, and that includes 4G, 5G, and microwave radio, satellite communications. Now, when I started the role, the idea was to have a holistic view as these technologies are developing, so we can make the optimal decision as to which technology we place where. It was also to ensure that we had, again, that holistic view across spectrum allocation, as more and more demand is placed on spectrum by a broad range of radio access technologies. But of course, in the last few years, we've seen the increasing integration of terrestrial and non-terrestrial. I'll touch on that as well as exploring our strategic ground segment today. So, we'll start with a quick overview of BT's space strategy. It often surprises people that BT has a space strategy. BT's been a space operator since the early 1960s. We've provided connectivity through our Earth station at Goonhilly for Telstar, for the original transatlantic video transmission, and have operated in space ever since. Clearly, over time, submarine cables took over and international satellite communications kind of started to decline somewhat. But now we've got this whole new era of new space and new exciting opportunities. So we relaunched our space strategy back in 22. So I want to talk a little bit about Madley, our satellite Earth station today. It's our ground segment, our strategic ground segment. And then also explore LEO developments. What does that mean for us as a telecommunications operator? A little bit about 3GPP NTN, a really exciting opportunity to augment terrestrial infrastructure, and that augmentation is a really important reality check, of course, even with the recent acquisition of MSS spectrum by SpaceX. They are not going to deliver national mobile networks. Let's be very clear about the practicalities of using that spectrum, but it's very powerful to augment existing networks. Say a little bit about multi-orbital solutions. We're now being asked to provide GEO and LEO as a package by many of our customers, and have done so recently. So I'll talk a bit about that. And then I want to say a little bit about airborne comms as well. We had the question about HAPS from Renato before, high-altitude platform systems. They are part of the story, they absolutely are. But also other technologies in that broader NTN space, such as air-to-ground to support C2 for drones and to support drone geofencing, for example. So there's a lot happening in that broader NTN space that will impact ground segments as well. And then just a brief summary. So this is our Earth station at Madley. This is our primary ground station. We've still got some capability at Goonhilly as well. But back to our space strategy. Okay, so I say relaunched in 2022. If you just Google BT Space Strategy, you'll find this document. It is being updated as we speak. There's a few things in there now that are a little out of date, and it will be relaunched probably early next year. The update will be finished this year, but there'll be a formal relaunch. But the idea behind this strategy was to build on our heritage, but also look to the future of space. And what does that mean for BT? And how do we best serve our customers using space as an augmentation to our fixed network? So there are 6 main pillars to our space strategy. From providing this downstream voice into government, into the ecosystem, as the UK's leading telco. But also, we're a global telecommunications operator. We operate in 180 countries around the world. So we've got significant geographical reach. And again, a lot of that is delivered on satellite still. Proactively engage with the wider ecosystem. That's part of the reason I'm here today and tomorrow, and looking forward to some really good conversations. We're currently going through a strategic upgrade program at Madley, so we're putting a lot more cross-site fibre in. We're introducing more L-band switching. We've just started a major program to upgrade all the drive systems and tracking systems on our satellites as well. But we really want to explore the role that emerging space technologies can play in how we serve our customers. The fundamental economics of space have changed as a result of 2 high-wealth individuals. And that's a game changer for us now. So I say, a part of my role is to understand, well, do you do this with microwave radio? Do you do this with 5G fixed wireless access, for example? Or do you do this with satellite? Or actually, if you want a high availability service, which 2 or even 3 of those would you combine, and how would you combine them? So some really interesting questions now as digital connectivity becomes fundamental to everything we do as a society. We really want to become thought leaders in terrestrial and non-terrestrial networks. This is something we're increasingly publishing on, we're increasingly talking about. We're very active in 3GPP as well. And foster disruptive thinking, and really help the UK to become a thought leader and indeed a major player in the space sector. It often surprises people what a large role space already plays in UK GDP, and there's an opportunity to grow that still further. And then leveraging our world-class research capabilities at Adastral Park. We're investing significantly in 2 new lab environments at Adastral Park, our space lab, where we're currently recruiting more NTN researchers into that research team. But also we've got a drone lab at Adastral Park and some integration between the space lab and the drone capability as well. And also our Satellite Communications Centre of Excellence at Madley, which we'll talk a little bit more about now. So what we actually did then, after we'd launched our space strategy, we started to look at what that really meant in detail. And we provided an update to the market back in 24, talking about our multi-orbital and multi-constellation space strategy. We're not tied to any particular satellite provider. We're not tied to any particular orbit. So indeed, GEO still matters. And that's an important message. GEO still matters. But clearly, LEO is going to take a lot of the low-hanging fruit, but it's going to bring a lot of new business into the market as well. And for those who are not familiar with the orbits, I suspect this audience all are, you could read 10 different textbooks and get 10 different definitions of exactly where one particular orbit starts and one finishes. But of course, in between those orbital domains, we have the inner and outer Van Allen belts, these areas of highly charged radioactive particles that can help to absorb that radiation from the sun and protect life on Earth. And that gives us some quite defined boundaries in terms of where we can deploy and operate space-based communication systems. So, Madley, what's it all about? I don't know if many of you have visited Madley, but we do open the site periodically for customer visits and kind of trade body visits, etc. But it's a significant GEO Earth station. We've got over 60 antenna systems operational on site at Madley at the moment, right the way from the large 32-metre C-band antennas, some large 19-metre KU-band antennas, right the way down to 75-centimetre antennas. We do a lot of TV receive only as well, so a lot of outside broadcast comes into Madley. So if you're watching the Champions League in the UK, chances are that content is coming in through Madley and then being connected into the UK television distribution network. It's a very secure facility, and again, we heard in the keynote this morning about the need for security, physical security and cyber security. This is a UK CNI, Critical National Infrastructure asset, and it's got all the security that goes with that in terms of kind of fencing, cameras, motion detectors, everything you would expect on a critical communications capability. It has 30 days autonomous power on site. We can run on generators for 30 days without even taking a fuel delivery. There are 2 complete power systems on site. Either one of them can run the whole site for 30 days, as well as everything else that goes with that in terms of battery backup, UPSs, HVAC systems, and all the necessary security that you have to put around those operational technologies. So it's not just about people hacking email and various other systems like that to get in and disrupt you, get into your files. It's about securing your operational technology that underpins the operation of your site. So again, significant ground segment. I just kind of like that photo, so I included it. It looks kind of fairly cool. And there's quite an evolution of history and technology there as well, of course, from beam waveguides right the way through to more recent KU band systems. Okay, so we also use that centre of excellence to base our satellite team and to do all of our customer solutions engineering as well. So this is a lab environment, so forgive the cabling. This is a work in progress, shall we say. But we have a lot of customers now. Let's take an example of festivals. So large festivals happen all over the world. In the UK, we have a large number, the likes of Glastonbury, Reading Festival, Creamfields, etc., many of which are internationally known. But of course, no matter what the mobile operators do in terms of putting additional capacity in, and they do a significant amount of that, if you want guaranteed service, then interestingly, satellite is an option. So we have certain Customers who want guaranteed capability for point-of-sales terminals and logistics ordering, but also want to provide some Wi-Fi access for welfare for staff, etc. on site. So that's this type of solution here. And interestingly, whilst that was originally 2 GEO systems, we now use a mix of GEO and LEO, as we'll see in a moment, to deliver those different capabilities, with GEO providing the high availability, mission-critical point of sales, while LEO provides significant capacity and lower latency for the welfare services. We also do a range of mobile backhaul services. So as cellular networks expand to ever more remote regions, and we'll see a little bit of that later, satellite backhaul becomes an increasing consideration. Now, initially, we started off with GEO-based SATCOM. We're now also delivering LEO-based SATCOM, and we'll see some examples of that as well. In terms of satellite access, we work with a broad range of providers. We've been a teleport operator for many, many years. So we've got a lot of established commercial relationships with SATCOM providers. And we can then work with them to find the right solution for a particular customer requirement that integrates in the optimal manner with our ground segment. Anything C-band, KU, we can land directly in Madley. We work with some partners on some KA access. We do host third-party antennas at Madley as well, and that's a growing business for us now, as we're actually hosting capability, providing the security, providing on-site first, second-line support as well for customers, and that includes other systems such as Ka-band and potentially other frequency bands in the future. We're just about to install our first optical uplink into our research lab at Adastral Park as part of a major project where we're going to be doing significant work to characterize optical to satellite, ground optical to satellite communications. And that includes an environmental chamber where we'll be transmitting a beam and then introducing various impairments, again, to help develop that level of knowledge as to what these link budgets need to look like. We know that about radio, of course. We've been doing it for a long time. But in the optical domain, what does this look like? And what do we need to be standardizing and agreeing within the ITU to ensure that we can deliver reliable optical connectivity? And of course, having a global terrestrial fiber network is an advantage in that regard because optical gateways can be placed around the world with low latency, high speed connectivity, connecting them back to the source of data such that if you have a weather impairment, you can switch very quickly to another optical gateway. And optical gateways will be game changing. They are critical. If you model the total satellite capacity requirements in the future, there isn't enough RF spectrum. There's a lot of competition for that spectrum. So again, it's an area that we need to develop. So, LEO Centre of Excellence. We've been working with LEO for a number of years now. We signed the first global distribution agreement with OneWeb. We also now have a partnership with Starlink as well. And we're working with both of them on a range of applications. Our Centre of Excellence at Madley developed customer solutions, working closely with our research team at Adastral Park. So undoubtedly, LEO mega constellations are changing the world. One of the questions I've got in my mind at the moment is, when will LEO be cheap enough that I can deploy it to every one of my 20,000 cellular base stations, just as resilience in case the fibre fails or the microwave fails? What point does it have to get to in terms of price point, capacity, availability, etc., to make that viable? LEO's going to open up new opportunities as well. It is bringing new markets, it's bringing new connectivity in its own right, and there will absolutely be some GEO substitution. Let's not kid ourselves here. But GEO still matters, as does MEO, as does HEO, pick your favourite orbit. But they still matter, and they're part of the overall solution set. So as a use case, with some of our LEO work, we've worked with Eutelsat OneWeb on mobile backhaul, and you can see a very remote cell site here, originally connected on GEO. And the problem was we were supporting applications like mission-critical push-to-talk, which made it really challenging with circa 700 milliseconds RTT for the users to really get the maximum experience without specialist training. So we initially introduced a dual parabolic user terminal to do some LEO testing. We invited the users along. You can see some of our critical comms vehicles at the back here. The users came along, they did some MCPTT testing, and they said, right, we've got the benchmark, you can now switch it onto the satellite. Hang on a minute, I've got nothing else here but satellite. That was LEO. Wow, we like it. That was indistinguishable from terrestrial transmission to support mission-critical push-to-talk voice. So that was game-changing. I was hooked at that point as a network architect. I now need to build this into the network. And obviously, some challenges with the practical deployability of this type of user terminal. But then as soon as we get to flat panels, we've got more options. And of course, that market is continuing to grow. We then started to work with Starlink as well. You can see an example of a Starlink installation. This is the premium business terminal on a base station site. Very low footprint. It's very simple to put these things at the top of towers as well, so you don't have to worry about obstructions. So that size, weight and power is massively important. And I should stress that with both OneWeb and Starlink, we have a direct interconnect from the POP. So we're not carrying this traffic on the internet, we're directly interconnecting with them and taking the traffic directly from their core network. So again, that enhances security, it enhances performance, and it makes the overall service more deterministic. So again, in terms of that ground segment, that data center interconnect, data center infrastructure is critical. And then you see me, I'm 5'11", the Mark 1 me there, holding a Starlink Mini, which we're playing about with for certain other use cases at the moment. But again, incredible. I walked up onto the roof of the building with that terminal, and within a couple of minutes of being on the roof, I was connected. I had Wi-Fi to my phone and a satellite communications link. So, why is satellite backhaul important to us? And even from a resilience perspective, why are we using it more and more to back up terrestrial? Here's an example of a site we're building at the moment. This site's now operational. The only way we can get to this location in the north of Scotland is via helicopter. It is that remote. So it's not the only site we do like this. We've got a growing number of sites now that are in incredibly rural areas. They don't provide a lot of in-building coverage, but they provide a large geographical coverage, which is important, particularly for people like the mountain rescue teams in these areas, police. We've got increasing requirements from Coast Guard as well. And you can see the Starlink installation here, providing mobile backhaul in this use case. And this leads nicely into a chat about non-terrestrial networks as well. Because long term, do you build terrestrial sites like this, or in areas like this, do you serve them with direct-to-device communication from satellite, or indeed from HAPS? And I think that's an interesting techno-economic that we need to study and understand, and we certainly don't have a conclusion yet, but we're starting to understand the question set and the capability that's in the market to allow us to address these different use cases. Multi-orbital solutions. Again, the picture is very much a working environment here. We're testing different solutions, combinations of different solutions. And today, if you want to do multi-orbit with LEO and GEO as a combination, then you've got two completely standalone satellite systems, two completely separate contracts, and then you pop a router on the back end of them, and you effectively build an SD-WAN type solution, put your own policy on there to manage that. Moving forward, what is the development going to be in multi-orbital terminals? What is the potential there? I think it's significant. And what is the capability to start to co-host some of these gateways as well? Because one of the challenges you've got with multi-orbital solutions, of course, is differential delay. So it's okay if you say, well, actually my point of sales traffic goes that way, and that's an IP policy, everything else goes that way, they're two separate streams. But if you want to actually share data across the two, because you want to increase capacity or you want to guarantee resilience in a failure scenario, etc., then differential delay is a consideration. Even between different LEO operators, differential delay is a big, big issue. Even between systems on the same LEO operator, I was surprised to see how different that delay can be, depending what use of intersatellite links comes into play and what resulting ground gateways those two data streams feed to. So lots of interesting challenges, but again, we're being asked for this by customers, so it's something we're working on. So in terms of that wider integration of terrestrial and non-terrestrial networks now, you can see how this is all starting to come together. Clearly, Apple have been doing their own thing as well in terms of their emergency SMS service. We're seeing developments in this area from other operators as well. SpaceX have been very, very vocal with their agreements with T-Mobile US and others, and have recently started talking about their relationship with WhatsApp and WhatsApp messaging and WhatsApp voice over the direct to cell, as they tend to term it, or direct to device, I think, as we tend to call it, certainly in Europe. But you can see the broad range of use cases now that are starting to come together. 3GPP did a study some years ago now, which led into the entire NTN work stream. And I'll not read all the words there. It's a busy slide. I like photos to talk to rather than lots of words, really. But I'm just going to pull out 4 words from that conclusion. Ubiquity, mobility, broadcast, and resiliency. Absolutely critical factors as we address, firstly, the need to connect everybody on the planet. Not just on the land masses, though. There's a massive demand coming in from maritime and aviation for ever more connectivity, including IoT, but also high-end video as well for surveillance and security purposes. So this starts to tick some boxes. But let's be a little bit careful about what you can practically do with direct-to-device. Sometimes it may be better to have a traditional SATCOM link onto a ship with a 5G private network on the ship for certain applications, and direct-to-device to augment that in terms of resilience as well. So this is our view from a BT perspective of this evolving new space ecosystem. As I say, GEO, MEO, HEO, etc. all matter. The reference at the far side there, I was just somewhat vertically challenged on the slide, so I focused on LEO down. So direct-to-device, massively interested in that. We don't consider it a threat at all. We're the UK's largest mobile operator as well with our EE brand, but we consider it a really exciting augmentation of what we do. We deploy a lot of rapid response capability. BT has an emergency response team. We respond to disasters, be they floods, earthquakes, rail crashes, and that's both in terms of supporting the emergency services, but also in terms of supporting the local community and ensuring comms are maintained. Maritime, rural, we cannot have people unconnected, and we cannot have people without reliable connectivity. We need to address that, and we see solutions for that within the NTN space. Air to ground. There are 2 operational air to ground networks over UK airspace today. We've got the European Aviation Network, which Deutsche Telekom run, which uses some of our base station sites to transmit. And of course, the Emergency Services Network have a dedicated air to ground network for helicopter access. And that again is built as part of that wider mission critical network. And then drones, lots of different drone scenarios. We could put infrastructure on drones, we could geofence drones. There's lots of things we can do with drones moving forward as well. And inter-satellite links, of course, is an absolute game changer, both for enabling the practical deployment of LEO, given the small footprint, but also in the future, potentially for integrating different orbits into systems of systems. So, just a quick slide on HAPS, High Altitude Platform Systems. We were working closely with SPL, Stratospheric Platforms Limited. They've now been bought out. But still, they're developing a range of solutions, and we're hoping at some point to do a flight test. We've had their antenna systems on our site at Adastral Park, and we've done a lot of optimization work. We think HAPS is part of the solution set. Absolutely. Quite often, people will say, well, they've got to land every 3 or 4 or 5 weeks. It's not really like a satellite. But it's not, because they've got to land every 3, 4 or 5 weeks. You can actually get on board, you can change things, you can fix things, you can optimize things, you can put new kit on them. So again, the part of the toolkit is part of the solutions toolkit, and that's really, really quite important. So we will be doing further testing and further development, and part of our NTN research activity is specific to HAPS. We talked a little about skills before, so just before I summarise, I just want to raise some awareness. Within BT, we have an organisation called the Tech Fellowship. The Tech Fellowship is run by Engineers for Engineers. It's our professional development capability. Engineers can achieve the level of accomplished engineer, distinguished engineer, or fellow. We have 5 fellows within the company. And within that, we have a number of technical squads. And these technical squads are really about exposing more people in the organisation to different technology areas, to get diversity of thought, to help us develop product, etc. So you can see the NTN Tech Squad, or subset of it, about half of it here, at the Earth Station in Madley recently. So again, but knowledge sharing, learning, and exciting people about space and new space is absolutely critical. So to summarise, a real whistle-stop tour through BT's space strategy and our ground segment. Clearly, we could talk for hours about this stuff, and collectively, I'm sure we will over the next few days. But space is cool, isn't it? It's pretty awesome. But it's also a growing commercial opportunity. At one time, we heard that space was the final frontier. We absolutely need to replace that term with the next commercial opportunity. Space is going to change lots and lots of things. And we need to understand how we, as a community, and certainly from my perspective, BT as a business and the UK as a country, really exploit space to the maximum benefit. 3GPP will primarily be LEO-based, given the latency requirements and needs to work and move, provide mobility in and out, for example, of terrestrial networks. So the geo applications will be limited. But below space, in the stratosphere, we're going to see lots and lots of development. It's part of the story. It's part of the solution set. So airborne assets are critical. I'm of that age where I remember the Jetsons on TV, which may mean nothing to most of you. But basically, there's lots of drones flying around everywhere. We're heading to that world very, very quickly. We're going to see more and more drones flying around. Those drones need command and control, but also they need geofencing. And again, some of that will come from terrestrial, some of that will come from non-terrestrial environments, and it'll be that integration that enables that optimal solution. But the final bullet here, I think, is key. The integration of terrestrial and non-terrestrial will result in a truly global, heterogeneous network, ensuring high availability for mission-critical traffic. Now, when we think about mission-critical traffic, we often think about the emergency services, the military, the security services, safety of life implementations like railway signalling, etc. But a friend of my wife runs a small flower company, and she often goes to village fairs. And single lady on her own, she doesn't take cash, she only takes electronic payments nowadays for safety reasons. And if she's not got cellular coverage, she can't use that point of sales terminal. She now carries a Starlink terminal with her and takes her own solution. It takes her 2 minutes to plug in, power up. She's never had a problem. So again, having that backup to the terrestrial network, and having that mission-critical traffic, in that broadest definition, talks to the capacity we need and the ease of delivering solutions in a cost-effective manner. So I'm around for the 2 days. I'm really looking forward to engaging with you all. It's an absolutely fascinating topic, and thank you very much. Cheers.